Bismillahirrahmanirrahim. Hello, my dear students. I hope you are having a nice day. In today's lecture, we are going to discuss a problem 10 available in the book of Walter Rudin. This problem is actually related to find the complex root of a given complex number. This problem actually gives the formula to find the square root of a complex number. Firstly, we will solve this problem, and at the end of lecture, I will discuss an example how can we calculate the root of complex number by using this formula. What is the statement of this question? The question says that we have a two complex number that is equal to a plus b iota, and second one is w is equal to u plus iota v. A and b are the real and imaginary part of z, and u and v are the real and imaginary part of w. The real and imaginary part of z are given by magnitude of w plus u, square root of magnitude of w plus u over 2, and b is given by magnitude of w minus u over 2 square root. We have to prove that square of z is equal to w. In other words, we can say that the square root of w is equal to plus minus z. This equation holds if v mean imaginary part of w is non-negative, and w is equal to square of conjugate of z if v is non-positive, mean to say v is less than or equal to 0. Conclude that every complex number with one exception have a two complex square root. Focus on this phrase, with one exception, mean in case if your complex number is 0. For the zero complex number, its root is 0. So in that case, there will be no two square root. For any non-zero complex number, it will always has two complex roots. So firstly, we will prove this identity: z square is equal to w. I will prove this equation. Actually, what we have to prove, z square should be equal to w, and w is equal to u plus iota v. We take z square as z is a plus b iota, so this becomes a plus b iota square. By taking square, expanding square, we have a square plus b iota square plus 2 a b iota. This is equal to a square minus b square, because you know iota square is minus 1, so this becomes a square minus b square. And this is equal to iota 2ab. Now, if you compare this value of z square with this value, because z square is equal to w, we have to show z square is equal to w, and w is equal to u plus iota v. If you compare both real and imaginary part, we need to show that our u should be equal to a square minus b square, and v is equal to 2ab. So I will calculate a square minus b square, and we show that this number a square minus b square is actually equal to u. Similarly, we will calculate 2ab, and it should be equal to v here. So let us calculate a square minus b square here. A square minus b square. A square minus B square is equal to, what is the value of A? The given value of A is this. When you take its square, we have magnitude of W plus U by 2. Square root will be cancelled with square. So we have this plus, this is minus. Minus, after taking square of B, we have magnitude of W minus U over 2. By taking LCM and after some calculation, this is minus W plus U over 2. The magnitude of W is cancelled. The remaining is U plus U, which is equal to 2U over 2. This is equal to U, which is our required. Next, similarly, we show that the value of 2AB should be is equal to B here. Now we have to show that the value of V is equal to 2AB, so we calculate 2AB. 2AB. 2, what is A? A is the square root of W magnitude plus U over 2 square root into B. B is W magnitude minus U over 2 square root. We can enclose both of the values in a single square root like this. Applying the formula, algebraic formula A square minus B square in the numerator, we have 2 into, this is the square of magnitude of W minus U square over 4 square root. By separating the square root of 4 is 2, that will be cancelled with this 2. We have remaining W, magnitude of W square. What is the magnitude of W from here? As you know, the magnitude of a complex number is simply given by the real part plus imaginary square of imaginary part square root. So, but here we need, this is square of magnitude. So when you apply square here, we have remaining U square plus V square minus U square whole square root. This becomes V square whole square root. Now there are the two possibilities here. You know the definition of square root says x square is equal to positive x if your x is greater than or equal to 0, and this is equal to minus x if your x is less than 0. So applying this definition of square root over here, we can write this is equal to V if V is greater than or equal to 0, and this is equal to minus V if V is less than 0. V is less than 0. So this implies your 2AB is equal to V if V is greater than or equal to 0. That is required. That is required. So from here we can say that Z square is equal to W, and the W is U plus iota V, and U is equal to A square minus B square, and V is equal to 2AB, and this is possible when V is greater than or equal to 0. Similarly, you can prove its second part. In this part, we have to show that the square of conjugate is equal to W when your V is less than or equal to 0. You can do the same question by just replacing V is equal to minus B. Otherwise, you can take the conjugate of G conjugate here, which is equal to A minus iota V. Now taking square and solve this question repeatedly. Next, conclude that every complex number with one exception has a two complex square root. Okay, next we have to draw the conclusion about the number of roots of the given complex number. You will write conclusion. Here, z square is equal to w. By taking square on both sides, we have square root of w is equal to plus minus z. This shows there are the two square root of w given by these are equal to plus minus z. What is z? Our z is a plus iota b. Now substituting the values of a and b. So the square root of this complex number are equal to, what is the value of a? The value of a is given by magnitude of w plus u over 2 square root plus plus iota. What is b? b is magnitude of w minus u over 2 square root. So this is the first square root of complex number w in form of this number w and u. This is possible when the imaginary part of w, that is v, is greater than or equal to 0. If your v is non-negative, then to find the square root of w you will use this formula. And in case imaginary part of w is negative, that is v, then you will write the square root of complex number w is simply given by square root magnitude of w plus u over 2 minus iota square root magnitude of w minus u over 2. This is possible if v is negative. So these are the two square root of complex number, and this depend on the imaginary part of the complex number w whose square root we want to find. Next, I will elaborate this topic by using a very simple example. In this example, I will show how we can find the complex roots of a given complex number. So let us take a very simple example, and further, lastly, you will write these formulas are for any non-zero complex number. In case z is equal to 0, then there is only one square root of z, that is itself, that is equal to 0. Square root of z is equal to 0 plus 0 iota. Okay. Let us consider the complex number. My complex number w is equal to 3 plus 4 iota, and I want to calculate the root of w. You can observe that here the imaginary part, that is 4, is positive. So to find the square root of complex number, I will use this formula, and further you have to take care plus minus sign in both cases. Okay. What is the magnitude of W here? This is my U. My U is equal to 3. And what is V? V is 4, which is positive. What is the magnitude of W? The magnitude of W is simply given by 3 square plus 4 square is equal to 25, which is equal to 5. As V is positive, so we will use this formula. Square root of W is equal to plus minus magnitude of W. What is magnitude of W? This is 5 plus U. What is U? That is the real part, 3 over 2 square root plus iota magnitude of W 5 minus U, that is 3 over 2 square root. 5 plus 3, 8, 8 by 2, 4, square root of 4 is 2. This is 2 plus iota 5 minus 3, 2, 2 over 2, 1, square root of 1 is 1. So these are the two complex numbers which are the square root of W. 2 plus iota and minus 2 plus iota. You can verify very easily that your answer is correct by taking simply the square of these numbers. Square of this number should be equal to W. If you relate this problem with our question, this is our Z. Now, this is our Z. Now your Z square should be equal to W. Taking the square of these two numbers, 2 plus iota square, this is equal to 4 plus iota square plus 4 iota. This is equal to iota square minus 1, 4 minus 1, this is 3, 3 plus 4 iota, which is your W. So this satisfied the equation, Z square is equal to W. Similarly, when you take the square of this number, this will again 3 plus 4 iota. So I hope now you have a clear understanding how to find the root of complex number for any non-zero complex number, because the square root of any zero complex number is 0 itself. So if you find this video helpful, kindly like, share and subscribe my channel. See you in the next lecture. Take care. Allah Hafiz.